So we're going to look now at standard form and what it tells you about a graph and how to change standard form to other forms of a quadratic. So what does standard form tell you? You should remember from earlier discussion, but this is a review, that standard form tells you a couple things. The first thing you want to do when you're looking at standard form is look down here at the end. This C, that is always your y-intercept. And it is your y-intercept because, once again, a y-intercept is going to be where your x value is 0. So if your x value is 0, then this is 0 times b, and that's 0 squared, which is 0 times a. So this whole part with the x's turns into 0, and all you're left with is your c. So that's your y-intercept. The other thing that standard form tells you is up here at the beginning, and that is your a. Your a, just like with vertex form, your a tells you your stretch if it is stretched. And if a is negative, then that tells you that it has been reflected. In other words, if you have a negative value here at the beginning, your graph is opening down instead of up. Remember, your normal x squared is a U-shape opening up. So if that's negative, it's going to be a U-shape opening down. Changing a standard form equation to vertex form simply amounts to completing the square, which you've already seen. So we're going to walk through that again. In this example, we have 2x squared minus 8x plus 9. And our first step is to go ahead and separate out this 9. We're just going to group and leave 9 out there by itself and kind of ignore it basically until the end. And in order to complete the square, we do have to just have an x squared at the beginning. That's going to allow us to follow our usual steps to complete our square. And so in order to get just x squared at the beginning, I'm going to have to factor out that 2. So I'm going to have 2 times x squared minus 4x. And so now what we're looking at is we are ready to actually complete our square. Now at this point, some people like to draw the picture, some people don't. If you want to draw the picture, great. If you don't, great. Whichever way you like to do it. As part of my example, I'm going to go ahead and draw it. Remember, we're trying to build a square with this middle part. And so with that middle part, we have an x squared up here in the corner, which gives me x by x. And remember, this needs to be a square, so our length and width have to be the same. And so in order to get that minus 4x into this area model and still have it be a square, I have to split that negative 4x into 2 pieces, negative 2x there and negative 2x there. And those 2 pieces have to be the same, because if they're not, then it's not going to be a square. And so what that gives me is, on the outside, x times x is x squared, x times negative 2 is 2x. And so now I know that my last piece of my square, since this is 2 and this is 2, has to be a positive 4, because negative 2 times negative 2, positive 4. That means I need to put a 4 in to complete my square. Now my square is complete. I now have a perfect square. But I just messed up my equation because I added 4 right in the middle of it. And you can't do that. Not only did I add 4, but I actually added 4 twice because of this 2 at the beginning. So what I've really added is 8. And since I added 8, if I want my equation to still be the same equation it was, I'm going to have to subtract 8 to balance it out. And that's how I can finish completing my square. So now I'm ready to go. I've got 2. This part in parentheses, remember, is this square over here, which means it is x minus 2 times x minus 2, otherwise known as x minus 2 squared. And then I've got 9 minus 8, which is 1. And now I have vertex form. Changing to factored form is a different process. We're going to want to factor it, and we've been factoring by grouping. So that's the way we're going to go ahead and do this. Remember, the first thing you want to look for when you're factoring is a common factor to see if these three terms have anything in common, and they don't, so I cannot factor out a common factor. So I'm going to start factoring by grouping, and the way to start that is I'm going to take my 2x and multiply it by my 15. And when I multiply 2x by negative 15, I get negative 30. And now I need to stop and think of two numbers that multiply to give me negative 30 and add to give me negative 7. So if you have trouble with that, you can go off to the side and list some factor pairs of 30. It could be 1 times 30, but that's not going to work. Could be 2 times 15. That's not going to work. Could be 3 times 10. Whoop, 3 times 10. That'll give me my 7. It'll give me my 7 if I have negative 10 and positive 3. That will give me my negative 7. So then I have to ask myself, does negative 10 times positive 3 give me my negative 30? And the answer is yes. So this works for both multiplying to give me negative 30 and adding to give me negative 7. It must work for both of those, or else it's not the right pair. So now I'm ready to split that middle term, and that middle term is going to get split. Now, which of these two numbers you put first really doesn't matter. I just generally put them in the order that I think of them. So I'm going to split my negative 7x into a positive 3x and a negative 10x. And then I'm going to bring down my negative 15. I'm going to bring down my 2x squared. And there you see I got a nice drawing of a pair of pants. That's why some people call this the pants method. And so what I'm going to do now, factoring by grouping, I'm going to group these and group these. Technically there's a plus in between. You want that minus with the 10. It needs to go with the 10. And now I'm just looking for common factors. When I look in this first group, I see a common factor of x. This is x times 2x plus 3. Then in this second group, I see they have a common factor of 5. Make sure if there's a negative at the beginning here like this, that you factor that negative out as well. So that's going to be negative 5 times 2x plus 3. And if you've done your factoring by grouping right, then you've got the same thing here and here, and that tells you one of your factors is 2x plus 3, and your other factor is x minus 5. And now I have changed it to factored form. If you want to check that, all you have to do, multiply it back out and see if it gives you what you started with. If it does, it's right. This one's right.